Let's solve this question on cone. Let's read the question first. A circus tent is cylindrical to a height of 3 meter and conical above it if its diameter is given as 105 meters and the slant height of the cone is 5 meters. Calculate the area of the total canvas required. Okay, it's like a very twisty and wordy problem. Before we start the solution, the first and foremost is read the question twice to see what they have given and see and try to get clues from the specific words. And if you do that, you will see that this problem, although it's related to cone, it's a combination of two different 3D shapes. One is a cylinder and one is a cone, because the circus tent is cylindrical at the base and the top is conical. So if you try to sketch the visual, which I strongly recommend for every mensuration problem or any maths problem in general, these are some of the circus tents that if you see, the bottom is cylindrical on both the sides over here also, and the top is kind of conical on this side and this side. Okay, and if you want another visual, this is like a rocket, which is a perfect example of cylindrical here and conical here. Okay, all right, and our objective is to calculate the area of the total canvas required. So how much area will be required for all of this canvas? This canvas is the cloth. How much area will be required for this cloth? Okay, that's what we need to find. And since it's given as area of total canvas, the question is slightly wordy here. So let's see the solution here. Okay, so what I'm going to assume is they're asking us to find the lateral surface areas. For example, if this is a combination of cylinder at the bottom and cone at the top. Okay, so what we're going to do is we're going to find the lateral surface area of this cylinder at the bottom and the lateral surface of this cone. And when I say lateral, we'll assume that the bottom of the cylinder and the top of the cylinder, the circular bases for top and bottom, are open. It's more like hollow, and likewise from the cone. For example, if you see in this diagram, if you see this white space, we can consider this as open. There's nothing there. It's not closed. Whereas in this case, it's gray and it's closed. So we are not going to consider that. So the way we'll consider this is, let's say we have a cylinder here. Okay, so we are not going to consider this circular top and bottom. We are going to just consider the lateral portion. And similarly for the cone, assume that it's kind of a birthday cap which is open from the bottom. So we're going to just consider the lateral surface area on both the shapes. So let's assume that. So in the exam, whenever you get these questions which is kind of wordy and you're not sure what they're asking, just make an assumption and then solve. So whenever there is a confusion in the question itself, you will still get the marks, and we can always expand based on our assumption what we are trying to solve here. Okay, so the area of the total canvas is the ask here, and we have plotted the visuals, and whatever is the given data points we have plotted on the combined schematic of cylinder and cone, where we have the height, slant height. Again, we have to don't get confused between the slant height and the height of the cylinder. So we have a slant height, which is this portion. We have the height of the cylinder, which is this portion. We have the diameter. By virtue of that, we'll also have the radius, because we can do diameter by 2 for the radius. Okay, so we have all the points. The only main difference or the only challenge is to recall the formula for the cylinder surface area and the cone's lateral surface area. So what do we have? Based on our assumption, the area of the total canvas required is going to be equal to lateral surface area of the cylinder and lateral surface area of the cone. Like I said, the lateral part, we'll keep the bottoms open and the tops open. We'll just consider the lateral part here. Okay, and if you recall, the lateral surface area of the cylinder is 2 pi RH, and for the cone is pi RL. If you don't recall, check out my other videos. But as a quick reference, right, always keep this in mind. If this is a cylinder, and this is what I've copied from my previous episode, so you'll get detailed version of this in the earlier topics. But just as a quick reference for extra notes in the exam, if you don't recall the formula, assume that it's a cylinder, and every 3D shapes originates from cylinder. We can make connections to that. So take the cylinder first, and when you say lateral, we're talking about this part. And if you cut open this part converts into rectangle, and the dimensions of rectangle are going to be 2 pi r, which is the circumference of this, because when you open that, it becomes the length of the rectangle, and the height remains the breadth. So 2 pi r into h is going to be your areas or the lateral surface area for the cylinder. And since we're not going to take the areas of the closed circular bases, the top and the bottom, we can ignore this too. So we just consider this part, okay, 2 pi r h, and that's what you get here, 2 pi r h. And similarly for the pi r l that you see here for the surface area of the cone, if you remember, I had explained in detail how to calculate that based on the area of the sector, and this formula comes from that, where you see pi r l. Again, if you need a refresher, please check out my previous topic on cone on how to calculate this area, but it's a pi r l. This will take into consideration this radius and the slant height, which is the radius of this particular sector. So we have it here, and the rest is simple substitution. There's nothing left in this problem because you already have it. So if you see from the given points, you have the slant height, the height of the cylinder and diameter, and hence the radius. So you put all the dimensions here, where instead of the radius I'm going to use d by 2, which is diameter by 2. Plug in all the values, and as much as possible keep the pi's to the last, and finally when you have a simple expression, multiply the pi, and you will get the area of the total canvas required is equal to 1813.35. And we should not forget that we have to add the unit. Since the given units are in meters, area is always going to be measured in meter square or square meters, so we add the square meters. And that's how we calculate the answer for this, or solution for this problem. Read the problem carefully. Whenever there's confusion, you make an assumption and move on. But let's say you want to extend it and you're not sure, so you can always say that, okay, I'm assuming the lateral surface area, and you can solve using this formula. At the bottom, you can add a note that if the question is asking about the total surface area, then you just add these two areas to the answer, to this 1813 answer, pi r square twice. So you add this 2 pi r square, radius is given to you. So that will assume that you're considering that the basis here is going to be closed at both the sides for the cylinder, and then you can add that, which in case you're going to assume that there is a gray color base here which is closed, and also at the top here there's a gray color base which covers this, which is closed, and then you're going to add that area. You can make an extension to the assumption and also do the quick values, because it's not difficult to multiply, and that way you can foolproof your answer. Otherwise, make a reasonable assumption and proceed, you'll still get your marks. So that's a wrap up on how to calculate surface area of a cone, and this is one of the problems under cone for mensuration, and I'll see you in the next topic.